Um, 2 cos squared theta looks close to a one of the double angle identities that we have. Does it? What does it look like? Anybody? Yeah, Dorian. Yeah, nice. If it had a -1. So I don't know if you want to write this down. Just watch for a minute. This isn't often very helpful because the right side is more complicated and we're going to work on that side. However, there is the odd moment where we can do a little trick like completing the square. So if this had a -1, well, can't I just do that? Cos squared x -1, but then I would have to add 1. And then that would be cos 2x plus 1. But in this case, that doesn't really help because so I don't like, why is he showing us this? Well, I don't know. It's just something that I thought of that comes up rarely. Don't start trying it too often. You really have to know that it's the right thing to do. But there's no reason why you can't do that. And sometimes little tricks like that really do help in sort of particular cases. Anyway, I think it's easier to work on the right side in this case, so we're going to go back and do that. And like I said, there's a bunch of different ways that you could solve this one. I could take the sine squared and change it into something. I could take the 1 and change it into something. It really depends on how you see it. So I'm going to try with the 1. And if you want to try with the sine squared, you could see that it would be the same. This one's nice because when we're subtracting 1, we got to remember to put it in brackets. So what would I change 1 into? Cos squared x plus sine squared x, Pythagorean identity, which is 3 cos squared x plus sine squared x minus cos squared x minus sine squared x. And so that's sine squared x minus sine squared x. And this is like terms. This is like 3x minus 1x, right? You've got 3 cos squared x's, and you're taking away 1 cos squared x's, so that's it. You're done. Like I said, pretty easy one once you see it. And I could have also replaced sine squared x using a Pythagorean identity or something like that. But yes?
Couldn't you just have changed the sine squared x minus 1 into negative cos squared using Pythagorean?
Yeah, same thing. Yeah, sure. So that's what I'm saying. Like, however you see it, there's lots of different ways to do it. You could change the sine squared x into 1 minus cos squared x or whatever as well. And like it would all work out, right? There's lots of different ways that you could do it, and it would only take a couple steps. It's not a matter of which one's easier. It's just which one you see. Okay, good. Next one. This is another easy one, but go ahead and try it. I think yesterday we did one like this where I like to rewrite the left side or the whatever side if it's a reciprocal identity. It's often helpful. So what do you notice?
The bottom left or right side is the double angle.
Right, and why would that be? I mean, often if you see those, you're probably thinking, oh, we learned those formulas because we're going to use those formulas, right? Like, but not only that, what's the other reason why you might think that's a good first step? Ross, you know?
Because once you change it, there's a cos in it.
Okay, good. Yeah, nice. I like that. Any other reasons? The left side has just an x, so we obviously need to get rid of the 2x part at some point, right? If the left side had a 2x in it somewhere, then you might not use that identity. So 2 sine x cos x, and then that's like 2 divided by 2 is 1, sine x divided by sine x is 1, and that's it, we're done. Easy. Left side. Okay, let's see, what do we have? Different kind of question. Use technology, you don't necessarily have to write this whole thing down, but we're going to do something with that expression. So use technology to graph 1 minus tan squared x over 1 plus tan squared x. Make a conjecture about another expression that is equivalent, and then prove your conjecture. There's a question in the textbook that is similar to this. So here's our graph. There's 1 minus tan squared over 1 plus tan squared x. What does it look like? Cosine, that is compressed. So what would be the equation for that? So 1 minus tan squared x over 1 plus tan squared x equals cos 2 theta or 2x. So a 2 is like a horizontal compression, right? By a factor of 2. Nice. And how do, if you're wondering how do we know that, we look at the let's see. Ooh, is this going to work? Okay, we'll look at it right here. Look at the period, right? So period, usually this is the spot where the cycle repeats, and that would usually be at 2 pi, so it's been cut in half. It's at pi. Very nice. Okay, so now I'm going to leave this with you for a few minutes, and I will put the solution up sort of after, but see if you can get this one going. What would you start with? What would you do?